Hello everyone, I am Rajiv Saxena, Associate Professor, Smriti College of Pharmaceutical Education, Indore. In today's video lecture, we will discuss about the laminar airflow equipments. Laminar airflow equipments are considered to be the most essential equipment if we have to create certain aseptic environment. As discussed in the previous videos, that there are certain products, especially if we are talking about any pharmaceutical industry, then definitely there are certain products that need to be sterilized in nature. That is, it should be free from any contaminating microorganism. So if we are in the process of compounding or dispensing or formulating these categories of the product, then the environment in which we are doing this type of unit operations should be free from any contaminating microorganism. We know that we have also discussed about these various sources of contamination in any pharmaceutical industry. So, as per the discussion, the atmosphere is considered to be the most important source of contamination. It is having the presence of the air that can carry away the microorganism from various soil and various environment. It can also have the presence of various infectious droplet. So, in short, we can say that the atmosphere is considered to be the major source of contamination, especially in the areas where we need to dispense the molecules, the drug component or the formulation that is necessarily to be sterilized in nature. So, in that area, the concept of laminar airflow equipments plays a very important role. Now, the laminar airflow equipments assures that the air which is available with the help of the laminar airflow equipment is 99.97% pure. Means it is not having the presence of any contaminating microorganism, and definitely it will provide an environment in which we can easily go for the compounding of these categories of the formulation in which the sterility is most essential. Now, the laminar airflow equipment is actually available in two different versions. It is also available in the vertical form and it is also available in the horizontal form. So, as you can see in this diagram, we have created here the vertical laminar airflow equipment. So, the similar type of arrangement is also available with the horizontal model. So, one by one we will discuss about what are the different essential components of laminar airflow equipment. So, as you can see in this diagram, first of all there is the presence of the working surface or the working bench in which we are performing any aseptic transformation or any aseptic operation. Suppose if we are talking about any microbiological laboratory, so definitely there are so many methods are available, so many experiments that we have to do, and those experiments are actually performed in the aseptic environment. So actually this workbench is actually the place where we can easily go for the performance of any aseptic method. So before using these workbenches, first of all we need to assure that these workbenches also should be free from any contaminating microorganism. So the most common way is wiping these working areas with the help of the alcohol. We know that alcohol is a very good disinfectant. Maybe we can go for the use of the 70%, 80% or 90% of this alcohol solution, and then when we are wiping these working areas with the alcohol, then definitely it will assure that in the working bench no contaminating microorganism is available and you can easily start your experimentation. Now, apart from this arrangement, apart from this wiping with the alcohol, certain light fixtures are also available. Now, in this light fixture, definitely will provide the light to the area so that we can easily perform the experiment. But apart from the light, it is also having the presence of the ultraviolet radiation arrangement. Now, this UV bulb also assures that before using this laminar airflow equipment, we can expose the internal environment of the lab with the ultraviolet radiations. We also know that the ultraviolet or radiation is also having the lethal power against this microorganism. So once we are wiping the working benches with the alcohol and then we are exposing the laminar airflow areas with the ultraviolet radiation, that combinedly assures that inside that area where the unit operation has to be performed is actually free from any microbial contamination. Now, so this is all about the working surfaces and about the light fixtures. Now, you can see in this diagram there is a presence of the airflow. Means certain air is actually flowing inside this laminar airflow unit. But this is not actually the air which is directly we are getting from the atmosphere, but it is actually the air which is coming from the specialized filter which is called as the Hepa filter. As you can see in this diagram, there is a presence of a specialized filter which is called as a Hepa filter. The full form of the Hepa filter is high efficiency particulated air filter. These are actually the membrane filter, or these are actually the microbial filters that does not permit the entrance of any microorganism inside that area where the aseptic experiment or aseptic transfer or any aseptic operation need to be performed. So what we can conclude here that it is having the filter arrangement that actually filters the air, and what it filter? It will filter the microorganism. So inside the air, if certain contaminating microorganisms are available, so they cannot process the Hepa filter. So whatever the air that we are experiencing in this area is actually free from any microorganism. Okay, so the main function of this Hepa filter is that it will not permit any microorganism to go through this Hepa filter. So definitely we need the air, because here Hepa filter will actually filter the air. So there has to be certain sources of the air. So as you can see in this diagram, there is an arrangement of the air inlet and the blower. So this is a basically a fan-like arrangement that actually generates the air and will actually flow the air inside this laminar airflow equipment. It is also having the arrangement of the supply plenum and the air diffuser that also help in the continuous supply of this air from the blower or from the air inlet towards the Hepa filter. So it means the air is generating from some places, and then that air is actually directed towards the Hepa filter, and what Hepa filter will do? That Hepa filter will filter the air, and filter in which form? That it will filter the presence of any microorganism. So whatever the air that is coming out of the Hepa filter is actually free from any microbial contamination. Some in this assembly, some pre-filters are also available that also help in the reduction of the count of any particulated matter before entering into the Hepa filter. The size of the Hepa filter, the pore size of the filter that is available with the Hepa is around 0.3 microns. So that size actually assures that no microorganism can process this Hepa filter. So in short, we can say that this is actually the area where we can perform the aseptic transfer or any aseptic experiment. Why we can perform that experiment in this area? Because in this area there is no microbial contamination is available. Suppose if we are not using this laminar airflow and we are using some clean room, and we are cleaning it with the help of the disinfectant, but again we cannot assure that in the clean room no microorganism is actually available, because if we have to go for any aseptic transformation or any aseptic experiment, then definitely we need to assure that in that area no microorganism should be available, because if any microorganism will be available, then definitely it can transfer into our experiment, it can transfer into our parenteral formulation or any pharmaceutical product that need to be sterilized in nature. Okay, so definitely these type of equipments or these type of assemblies are very essential, especially in the microbiological laboratory and also in the areas, especially if we are talking about the pharmaceutical industry. So definitely there also these type of laminar airflow equipments plays a very important role. Now, as you can see in this diagram, there are two type of airflow patterns are available. Number one is a unidirectional airflow pattern, and number two is a non-unidirectional airflow pattern. Okay. Now, as discussed in this diagram, as you can see this, it is basically a kind of a equipment. It is basically a kind of a machine in which we can go for the performance of the aseptic experiment. Okay. But suppose if we want to transfer these type of principle inside the pharmaceutical industry, where we need to go for the production of a very large scale, large number of the pharmaceutical product that need to be sterile. For example, the parenteral product or any ophthalmic product. Then definitely inside this small area, we cannot go for the larger production of these type of the product. So it is also considered that we can translocate, we can transfer these type of arrangement or these type of principle inside our room also. Okay, as you can see in this diagram, you can see that this is basically, you can assume that this is a room in which some aseptic operation is actually performing. So inside that room, some arrangement of fan is available that is generating the air, and that air is actually transferring through the HEPA filter. So whatever the air that is coming out of the HEPA filter in the form of the unidirectional airflow, it is available inside this room, and inside this room definitely you can perform any aseptic method. Suppose in your methodology in which you are preparing any parenteral product, and in that parenteral product, if suppose terminal sterilization is not available, so during the operation or during the manufacturing process only we need to sterile the product. Okay, so in that case definitely the area should be in such a way that inside that area no microorganism should be available. For example, this is a room in which we have to go for the sterilization of any parenteral product, so definitely in the atmosphere no contaminating microorganism will be available. So in that case definitely these type of larger laminar airflow units will help you, because it is having the arrangement of the fan that is generating the air, and that air is actually transferring through the HEPA filter, and whatever the air that is being experienced by the room, either in the form of the unidirectional flow or maybe in the form of the non-unidirectional flow, is actually free from any contaminating microorganism. So in short we can say that, especially if we are talking about the microbiological experiment, or maybe we are talking about any pharmaceutical product which is of the sterile category, then definitely in both the cases the laminar airflow equipments or the laminar airflow units plays a very important role. Now, as discussed earlier, that the laminar airflow unit actually assures that whatever the air that is available is actually free from any microorganism, and the efficiency of the laminar airflow is around 99.97%. Okay, so time to time we need to validate the efficiency of the laminar airflow equipment, because it is very important that whatever the air we are experiencing or whatever the area that we have created as aseptic should be maintained for a longer duration of the time. Okay, so time to time in our industry, what we need to assure that whatever the HEPA filters that we are installing in our laminar airflow equipment should work with the full efficiency, and it should give 99.97% result. Okay, so at time to time we need to evaluate the efficiency, we need to evaluate the HEPA filter. So for that evaluation, different methods are actually available. Okay, but the most common method is actually called as the DOP test. Okay, the full form of the DOP is dioctyl phthalate test. Now, this dioctyl phthalate test or the DOP test is a very common test which is routinely performed in any laboratory, or it is routinely performed in any pharmaceutical industry, that actually assures that your HEPA filter is working with the full efficiency. Now, dioctyl phthalate is basically a volatile liquid, and under pressure it is actually converted into some vapor, or we can also call that it is also converted into some smoke type of a thing. Okay, so what we have to do, that we have to convert the volatile DOP into its vaporized form under the pressure, or into its smoke form. So in short we can say that initially we need to generate the DOP smoke. Okay, so that DOP smoke is actually entered with the help of the supply plenum into this laminar airflow equipment. Okay, so again I am repeating that for the evaluation of the efficiency of the laminar airflow, the most common test which is adopted inside the laboratory is actually the DOP test. And what is the full form of the DOP? That is dioctyl phthalate test. Okay, dioctyl phthalate, initially it is available in the form of the volatile liquid, but under pressure you can convert that liquid into its vapor form. So once this vapor will be generated, or once that smoke will be generated, that smoke will be supplied to the supply plenum, because we know that the supply plenum is actually responsible for the constant supply of the air, and it will direct the air towards the HEPA filter. So these smoke will be directed towards the HEPA filter, and under this pressure, these smoke particles will be allowed to transfer through this HEPA filter. Okay, but the size of the smoke particles or the vapors of the DOP is around 0.3 to 0.4 microns. So ideally, these vapors should not move across the HEPA filter. It means whatever the vapor that we are providing to the supply plenum, it will be directed towards the HEPA filter, but the HEPA filter should have the capability to hinder the movement of this DOP particle. Okay, so if the no DOP particle will be transmitted across the HEPA filter, then we can assure that our HEPA filter is actually working with the full efficiency. But otherwise, if we are observing the presence of the DOP particles across the HEPA filter, that is actually measured with the help of some specialized machine, which is actually called as photometer probe scanner. So this photometer probe scanner will actually scan the presence of the DOP particle. Okay, so if any air that is containing the DOP particle is transferring with the help of the HEPA filter, should not have the presence of the DOP particle, and this probe sensor should not sense the presence of this DOP particle across the HEPA filter, then only you can assure that your laminar airflow equipment is working with the full efficiency. But otherwise, if your sensor is actually sensing the presence of the DOP particles, maybe in this area, maybe in this area, or maybe in this area, then definitely it is why? Because your HEPA filter, maybe it is damaged, or maybe there is certain technical problem with the HEPA filter that is not able to stop the particle of the DOP, and definitely in that case we need to go for the repair or any change in the HEPA filter, because we can say that the HEPA filter is not working as per the set standard, means it is not giving 99.97% result. Okay, so these kind of the DOP test is actually routinely performed in any microbiological or pharmaceutical industry in order to assure that the HEPA filter is working with the full efficiency. So here we can summarize that laminar airflow equipment is very essential in the microbiological laboratory or any pharmaceutical industry which is involved in the production of sterilized product, maybe parenteral product, maybe ophthalmic product, because it is actually providing the area which is free from any microorganism, because in that area only we can perform these categories of the operation. Otherwise, from the atmosphere which is having the microorganism can directly enter into our experiment, or it can directly enter into our pharmaceutical product, and definitely the sterility cannot be assured. So in that case, the laminar airflow plays a very important role. Various laminar airflow models are available, but these models are actually divided into two categories. Number one, the horizontal model, and number two is a vertical model. Okay, so this is the basic arrangement of the laminar airflow unit. But if you are talking about any room, then this type of arrangement can also be done inside the room with the help of unidirectional airflow pattern and by the use of the non-unidirectional airflow patterns. Okay, so it will also create the atmosphere, it will also create the air, it will also generate the air which is free from microbial contamination. And time to time, whatever the method that we are using, maybe for the microbiological laboratory or maybe for the industry, time to time we need to assure that your HEPA filter is actually working with the full efficiency. Okay, again I am repeating, the size of the HEPA filter is 0.3 microns, and we need to perform the DOP test in order to assure the integrity of the HEPA filter. And if the DOP test is failed, then definitely we need to repair or we need to change the HEPA filter, so that continuously we are getting the air which is free from any contaminating microorganism. Thank you.